Very good morning to you all, ladies and gentlemen. Thank you very much for joining with us in this slow for Saturday morning. And thank you very much for joining with us, because today we are here to not just for any other webinar, but I believe we are here to fulfill a national obligation. As you all know, right at the moment, we as a country are in a critical situation. And as a country, what we need right now is new ways of thinking. Innovation, novelties, invention, is that what it is what we require that for us to move forward as a country at the moment. So ISL, or Institution of Engineers of Sri Lanka, has been an apex body, professional body for engineers here in Sri Lanka, and has had that national duty or obligation of serving its country, building our nation through different disciplines, giving the best for the nation. Now, without forgetting that responsibility, we are here with another tremendous effort taken by this professional body, which is UIY, which is called as the Young Undergraduate Inventor of the Year 2022. Now, Undergraduate Inventor of the Year, also known as UIY, is a program, it's a competition conducted for universities here in Sri Lanka, especially focused on the engineering faculties in universities, where they will be given an opportunity to test their limits when it comes to innovation and invention. As you know, the technology field is always driven by the inventions and innovations. So it's all about finding that capability, that inner ability that you have to serve our mother nation. So with regard to this entire program, we have conducted the series of webinars, and it is known as the INVEN Ovations. Now we are joining with the second segment of this webinar series. Today, the webinar will be hosted by the ISS student chapter of University of Moratuwa. So ladies and gentlemen, once again, welcome you all to INVEN Ovations 2022, organized by ISA UIY in collaboration with the ISS student chapter of University of Moratuwa. All right, so just like I mentioned, tomorrow the upcoming weeks will be critical, because we'll be launching the special program of UIY. And these webinars, just like the first one and the second one, are focused on developing your soft skills, your experience, your skills required for this field of innovation and invention for us to be tackling these issues out there in the country at the moment. So it's all about technology-driven innovations and inventions. So today we have invited another prestigious guest to have a conversation, a virtual conversation with you. Now, virtual conversation has become a big part of our day-to-day life. I know some of you may don't like it, but hang on, because it's important and crucial. It's going to be a crucial event for both of us to learn something new out of this experience. All right, without further ado, let's start the program. And first and foremost, we have the welcoming address to welcome the virtual audience. My kind invitation goes to ISL UIY Subcommittee Secretary, Ms. Lakshani Patirage. Over to you, ma'am.
Yeah, hope I am audible and visible.
Yes, you are.
Yeah, thank you, Paul. Good morning, everyone. On behalf of the ISL Undergraduate Inventor of the Year Subcommittee, first and foremost, I would like to warmly welcome our today's session guest speaker, Dr. Sachindra Hemachandra, and ISL Undergraduate Inventor of the Year Executive Committee Chairman, Engineer Kasun Pereira, ISL Undergraduate Inventor of the Year Executive Committee Secretary, Dr. Kishu Kumar, and all the Executive Committee members of the UIY 2022. Next up, I warmly welcome everyone from the ISL UIY and GIY committees and all the participants who are joining with us today to make this event a huge success. Innovation is a newly initiated concept which is focused on sharing industrial experiences, expertise and exposure of middle-level field engineers with undergraduates while promoting creativity, required soft skills, invention, innovation, ideas to make us ready for future changes with the aim of bringing 2 decades to a same platform. Today's topic in innovation and learning, a lifelong journey. It's a very essential and a much excited topic for all the undergraduates who are joining with us today. As we all understand, this is a beneficial and a noble opportunity for us as young undergraduates. Finally, I would like to say, listen carefully and grab the best out of the best from Innovation second episode 2022. Stay tuned with us for many more. And so tomorrow we will be having the most awaited launching ceremony of the Undergraduate Inventor of the Year competition. So hope everyone will be joining hands with us too. So thank you very much. Over to you, Paul.
Thank you very much, ladies and gentlemen. That was Lakshani Patirage, the Secretary of ISA UIY Subcommittee for the year 2022, bringing us the welcome speech for our today's virtual session. Now, speaking of Undergraduate Inventor of the Year 2022, this particular competition will be focused on the mainly engineering faculties in the state universities in Sri Lanka, including University of Peradeniya, University of Moratuwa, University of Ruhuna, University of Sri Javardhanapura, Southeastern University of Sri Lanka, University of Jaffna, and Open University of Sri Lanka. So the competition will be based on these faculties, the engineering faculties of these above mentioned universities. And just like I mentioned, right at the moment, this is a very crucial moment for us to look into innovation and invention, to create solutions, to cater and to move forward as in one nation, despite all the difficulties. All right, ladies and gentlemen, next my kind invitation goes to the chairman of ISA UIY Executive Committee, Engineer Kasun Pereira, to address the gathering. Over to you, sir.
Thank you. Am I audible?
Yes, sir, you are.
It is said that a nation's supreme asset is its future generation. INVEN Ovation, the webinar series organized by ISL UIY Committee in collaboration with the most professional and trailblazing individuals, is conducted to foster an invention and innovation culture amongst the engineering undergraduates of Sri Lanka. As many of you joining our undergrads, I'm confident that you will experience a fruitful session of how to be ambitious with your career goals, the opportunities and the challenges faced down the road, aspiring as engineers, the achievements that awaits you for being innovative, and more importantly, how to dream big and fall forward. It's not every time you end up with a success story. It is the setbacks, the failures, the attempts, what will mold you of becoming an experienced engineer. We are at the second episode of INVEN Ovation with the presence of Dr. Hemachandra, a very charismatic individual who's willing to inspire you with his expertise, knowledge, and experience. Having said that, let me give you a quick insight of the UIY competition as well. We are about to launch the UIY competition 2022. The launching ceremony will be held tomorrow, that is May 1st. There is a Zoom event and it will be happening on 10 a.m. onwards. So on behalf of IESL, I request all of you to take this opportunity to compete in this event. And this is the platform to showcase your talents in the national arena. ISL is looking forward to give you the recognition that you deserve. Grab this opportunity and adopt the innovative culture, which has been seriously compromised by the generations before you. So stay tuned with UIY. Let's make impossible things possible with UIY. Thank you.
Thank you very much. Ladies and gentlemen, that was Engineer Kasun Pereira, Chairman of ISL UIY's Executive Committee. Now, ISL, Institution of Engineers Sri Lanka, has been, for years, has been the professional apex of engineers here in Sri Lanka. But transcending this duty of being a professional body, ISL wanted to empower the younger generation, youth generations, the innovations of the people, the undergraduates, and the future, the backbone of our country. That's why the sections like YMS and UIY was originated, just for empowering the youth of Sri Lanka and youth, especially the budding engineers, the amateur apprentice engineers who will be taking the role of engineering on the days to come. So this competition, the Undergraduate Inventor of the Year 2020, is going to be truly a remarkable and outstanding competition, because it's not going to be just a competition, but rather it's going to be a platform where numerous solutions will be introduced to the Sri Lankan arena. So today, the innovations, we have created this webinar series for you to grasp something out of it, some experience, some expertise, so that you can shape up your career, shape up your path to innovation, invention, providing solutions to the issues out there at the moment in the country as well as in the world. So ladies and gentlemen, for the second series, just like in the first series, we have invited another prestigious guest all the way from USA to join with us to have a virtual conversation. Now, we have been cursing the virtual platform for years, for being stuck and stagnated at the same point. But thanks to Zoom, we are going to welcome another prestigious alumni of University of Monotua, and also a prestigious product of Sri Lanka in the engineering field, who is currently residing in US, and he will be having this virtual conversation with us about this topic of innovation and novelties, especially when it comes to this education, higher education, and the undergraduate life. So without further ado, let me introduce our speaker for today, this profile introduction to our speaker. And our speaker is none other than Dr. Sachitra Hemachandra. Dr. Sachitra Hemachandra received his PhD in SM Electrical Engineering and Computer Science at MIT in 2015 with a specialization in robotics. He received his Bachelor's of Engineering, Bachelor's of Science of Engineering with first class honors for Electronic and Telecommunication Department, University of Moratuwa. And he's a past finalist of Chartered Institute of Management Accountancy in UK. Speaking of the experiences that our speaker has gained, he has worked as the staff tech lead manager for Perception at Cruise, self-driving subsidiary of GM currently. And also he has worked as the staff research scientist of tech lead of tracking of Toyota Research Institute from 2019 to 2021. And also he was the senior software engineer tracking for Waymo Google self-driving car project from 2016 to 2019. He's a robotist of the Google Robotics from 2015 to 2016, and also a research intern, Personal Robotics Group, BOSS Research and Technology Center in 2014. Speaking of his achievements, he was able to publish numerous publications in top-tier robotics conference and journals, and also he has numerous patents in self-driving. Also to notice that he is a winner of the gold medal for electronics and telecommunication best cumulative GPA, and also he was the second best performance in All Ireland GCA advanced level examination. Ladies and gentlemen, now without further ado, now I will hand over the session to our guest speaker and our resource person for today, Dr. Sachitra Hemachandra. Over to you, sir.
Hi. Thank you, Paul. And thanks everyone for inviting me to this session. Oh, wait, it's my background flipped. Interesting. Okay, is that better? Okay, let me see if I can. Okay. You guys can see the screen?
Yes, sir, we can see the screen.
Okay. Okay. Like I said, thank you very much for inviting me. This presentation was put up in a bit of a hurry, so appreciate your patience. Anyway, today I wanted to talk to you a little bit about innovation and learning. I tried to find a fancy title. So it's a lifelong journey. I think basically the idea that I want to convey is that I think innovation and learning is something not that something that you want to think about at a specific time. It's something that I think everyone should think of during their life in different stages. So I'm going to try to talk about some of these and what kind of opportunities there is for innovation and learning. So what is innovation? Innovation is basically kind of new idea or a method or a device or introducing something new. I think I wanted to put the formal definition because it's kind of the high level idea, but I think it doesn't necessarily mean that it's always inventing something new or filing patents or doing like cutting edge research. It can be that, but in a more personal level, it's more about growing yourself and thinking in new ways or trying out new ideas. And that doesn't necessarily have to always change the world, but it can change your life. It can change the life of people around you. And so in that sense, it's more, in some sense, it's more also about like innovating yourself and always growing yourself and taking new opportunities that can better yourself and your people around you. So I think one key thing about innovation is that it requires a lot of patience and willingness to take risk. And I think this is something that I think people who kind of innovate learn as they go along in life. And I think a lot of people learn to do this more and more as they grow older. But sometimes it's easier to take risk when you're younger than when you're older. So I think it's something that if you think about it at the right age, you can achieve more just by being willing to take this risk and trying to be more proactive. So I'm going to try to kind of outline the talk and maybe give a little bit of context of what I went through. And I'm not going to claim that I was most innovative at all these stages. I think there are different stages where I think we may have different types of opportunities to innovate, and we have different types of opportunities to grow and learn new things. So I think we all start in school, we learn different things, and then some people go to university. In my case, I went to University of Moratuwa. I also did CIMA as an additional program, and I was kind of interested in finance and economics and things like that as well. At University of Moratuwa, I studied in the electronics and telecommunication department, and then I actually worked for about a year and a half in Dialog Telecom, and actually was more on like the business side of Dialog Telecom. But I decided that I wanted to continue my studies further, and at that point, I applied to a PhD at MIT. But I was accepted to a PhD at MIT. So I did my PhD, took about 6 years. And after my PhD, I've been working in the industry in kind of research and development kind of roles, mostly in robotics and self-driving. And I'll try to give some context as I go along. So I think at a high level, I wanted to talk a little bit about the lessons that I learned. And I think at the start at school, I think a lot of our schooling system is set up in a very linear way. I think the most choice we have to make is, are you going to focus on mathematics or biology? It's a big choice, but I think once you decide those things, there's not as much necessarily of innovation in the learning stream. In some sense, I know that lots of people innovate or do interesting things as additional things like at school, in different clubs and things like that. And I think those are definitely interesting things. I think one thing is more, it does set you up for the next stages. So I'm not going to talk too much about how you can innovate at school. And I think given the audience, you guys are in undergraduates. So I think I focus more on that side of things. In undergraduate, it's definitely different than school. And I think it's definitely time where you can make more choices yourself. I think given the way that especially our undergraduate system is set up, that if you don't take the initiative, you do end up being flown through that corridor of, okay, take these classes, I graduate and I go to a good job. And I think that's certainly fine. I think if you really want to innovate and learn new things, and depending on what career path you would like to take, you ideally should take more active control of your life and your direction of what you're learning. I think having been there somewhat while ago, but still not too long ago that I don't remember, I think we all get into this mindset of, oh, I want to do the best classes, get all the A's, pick the best department, and this department changes depending on the years. When I was doing undergraduates at Moratuwa, it was electronics and telecommunication. I think maybe it's computer science now. I'm not not up to date, but so this is kind of a transitive thing. I think what's important is, I think first year, at least in Moratuwa and even in like universities like MIT, people take a lot of broad classes. You kind of get an idea of what are interesting topics inside these fields. And then ideally you take a decision based more on your interest and skill sets and where you kind of find the optimal overlap with those things. And then you decide your major. That doesn't necessarily happen, but that's potentially the ideal way of doing it. But I think then depending on how people look at it, you can take like the standard set of classes, all the classes that your friends take. And I did this to a decent level, maybe until towards like level 3, level 4. And then you're kind of drowned into this machine of doing assignments and taking 10 classes in a semester. And this is not the ideal situation. And maybe things have changed somewhat, at least in my days. There were semesters I think I took like 11 classes. And so you don't necessarily have the time to even breathe. But I think ideally you can try to take more active direction in what you're learning. So sometimes it's okay not to take the classes that are like guaranteed A pluses, or the thing that's always gonna just follow you into like some specific path you kind of thought was the most attractive thing based on the current fad. So what I wanted to say is that I think, and if I could go back, I would probably take more interesting classes and try different things in undergrad as well. And I think learning these new skills kind of help you innovate or just grow your mind and skill sets. And depending on what you like to go in, it helps you set that foundation very well. And I think there are classes, at least in even those days, there were classes which gave you some interesting opportunities to kind of do new things. And I think if you can find those classes or find those opportunities, those are good opportunities to grow and innovate. Like you might have classes that focus more on projects. You might be able to do interesting research projects. And then the final year project is another big thing that is a good opportunity to show your innovation skills, but also just to learn what it takes to kind of invent new things or just even doing research. And a lot of our thinking is that, okay, you go to college, you go to undergraduate and you get a good degree, you pass out with first class, and then you go to a good job, and that's it. But I think there's lots of different, it's a long journey, and undergraduate is kind of, in some sense, the start of that next stage of your life as a person with a career and responsibilities. But I think it's also just a start. So I like people who end up doing undergraduate degrees in electronics are sometimes managers, sometimes they're doing finance. I have friends who are like in very different fields than what they did in undergrad. Sometimes some people have even gone and become monks. So I think it's a very long journey. So, and the idea is that change will happen in your life anyway. So I think you have to be prepared to grow and change with it. And so if you learn the right things and do the interesting things at that age and as an undergrad, it kind of sets you up to succeed further in life, and not in a very linear way, but gives you more opportunities, and then you can try to select. And depending on what is the best thing at that time, you have more options to kind of innovate and grow as an individual. Anyway, like I said, take more risks. Perfect GPAs don't matter. I had a pretty good GPA, but I think just in general, I think especially depending on what you want to do, like GPA is not the end of the world. Like even if you're going to graduate school, GPA is only one simple thing that they look at. Most of these big universities, they care about how you can do research and things like that. So a good GPA might get you in the door to getting looked at, but that doesn't really actually get you the top opportunities that you want to get into. And I think another thing is kind of learn the fundamentals. And this is something that when we are like thrown at a lot of classes, you read through like linear algebra and calculus and all these things. And then you go into like all these complicated, very niche areas of optical communication or I don't know, signal analysis, all these deep, very niche areas, but it's the fundamentals that help you out further in life, depending on what avenue you take. Sometimes it's not those final classes because you can read that in like some white paper or paper and figure that out. But if you're doing research, it's the fundamental math and other things that really help you further in life. And I think that's something that I think you should value more, that you should value at least as equally as other more involved things. And like I was saying, do interesting projects. And I think there are a couple of opportunities to shine and also to learn how to do research and innovation. And those are like class projects and final year projects. And be willing to take risks. And another thing, depending on if people are thinking of careers in academia or even just going into like higher studies, is try to publish papers. Both it helps your writing skills and other things, also thinking process, so that you kind of structure out how you want to do new things. And a lot of cutting edge research that happens in public institutions or in these top companies like Google and Facebook, they are not isolated things where one guy sits in a office for like 3 years and come up with something new. Most of these are built up of things that other people do, but adding something novel, whether it's looking at a problem differently or trying to solve an incremental problem. And there are fundamental researchers, but sometimes fundamental research takes 30, 40 years to actually get recognized or realized. Things like deep neural networks were invented in the 60s and 70s, and only now are they really used. So there are fundamental researches that happen, and they might have impact as well. And they definitely have impact, but most of the innovations and things that happen are built on top of things that other people have done, which is a good thing in that you can get started more easily. And one other thing is be open to change. I think you have to be flexible. You have to take the opportunities that come your way. And sometimes it's good to reinvent yourself as you go along, whether it's in undergraduates or in career. Sometimes it's good to change jobs or try out different things, change your role, things like that. And this is more personal innovation as opposed to like really solving the biggest, hardest problem in the world. But I think that's more useful to people. So at least I hope that this advice is more useful to people than telling how to magically solve the hardest problem, which is not something any speaker can answer. And I'm going to dive into a couple of things. I think innovation can mean different things in life at different stages. And it may be because of your skill sets, because of the opportunities to really innovate. So in school, it might be one thing. In undergrad, it's something else. In graduate school, it's different thing. And at work, it might be different. And people innovate. Like people don't need to go to undergraduates to make new inventions or innovate. So in that sense, like this is just a path that I took, and I can give you my viewpoints and experience, but that doesn't mean this is the only way to innovate as well. So few advices for innovations in undergraduate studies, I think is another thing that I want to touch on is kind of looking at the right opportunities, like lots of internship opportunities. I know people who did internships at research labs. I think there's also a lot of Sri Lankan community spread out in the world. And some of these are professors in labs and other places like companies that do cutting edge things and invent new things. And this would be like a great opportunity for people to kind of learn how to start innovating and doing research. And research is only one type of innovation. So I will kind of more focus on that. But some of these things take some time and thinking ahead. When I was in undergrad also, I didn't really think too much about this. And typically you have these lotteries in those days at least, and you try to find a good company, or you try to interview some companies that interview you people and then select you. But if you think ahead, you want to proactively kind of reach out to places, look for these opportunities and kind of stand out. And then that kind of will unlock more career opportunities, but also just you can learn a lot more things by being exposed to different kinds of styles of doing things, or just learning from other people who are doing more advanced research. Like I said, take the right classes, broaden the knowledge and the horizons, and not always try to check off the requirement of doing, okay, I need to do 3 computer science classes or computer engineering classes to satisfy the requirement. I take the easiest 3 classes. That's one way to look at it. And if you're optimizing for your GPA, that's a fine way. But I think ideally you want to take things that are interesting and harder, even so that you actually learn new things and grow your skills. Class projects and final year projects also try to take things that are like allowing you to do something new, and but also not try to bite off a problem that is too large. A lot of things at least in graduate school and in research in general, is that you need to find the right problem and then solve that problem. Sometimes if you're writing a paper or doing research, you don't want to invent the whole thing. You want to focus on some specific thing, make assumptions about other pieces, or simplify certain other things and try to solve a specific problem. This, I think, is something people learn as depending on their career path. But so that's a way to look at it. And I think looking at literature and reading papers and things like that are a good way to kind of understand how people approach problems, how people kind of try to solve these research problems. And I think research problems are like other problems. You want to focus on the things that matter, like and not everything, which is not something feasible for anyone to do in like a short amount of time. Even like whatever, six months or 8 months in addition to taking classes is not a lot of time. So these are kind of things that will help you kind of learn how to do research and invent new things, and this will help you further down in life as you go on to next stages in life. Like I said, plan ahead, find areas that you're passionate about. This is something that can be tricky. When I was studying, I had lots of different interests. I was good at different things, and sometimes it makes it difficult to focus on a specific thing. And sometimes you don't know. Even people who go into PhDs change topics like a year or two, and sometimes change even departments. So it's never a set thing. And sometimes it takes time, and sometimes you don't have to decide. Sometimes it's okay to keep your mind open. But learning to do research doesn't necessarily mean that those skills are not applicable to other things, or learning to innovate or think and solve problems. So, and that's why I think doing research or doing interesting things, even in certain classes that maybe the class itself might not be where you want to really go further in life, but it gives you an opportunity to how to solve these interesting problems. And at least in my opinion, a lot of accessibility of research and a lot of material has come a long way since my days. We have a lot of access to internet, other things, lots of papers being published by lots of cutting edge companies like Google and other things. It depends on some areas are ahead than others, and some research or doing things are easier than others. And like computer science or maybe even electronics, it's easier than like maybe chemical engineering or material engineering. And especially in Sri Lanka, where I think we have to deal with resource constraints, it's not necessarily the easiest thing or a broadly applicable thing, but at least in certain fields, it is easier and more accessible, and at least, and maybe in other cases, we can change things and improve things to get more accessibility in research in undergrad. So, and this will, like, reading papers, doing things is a good way to get that experience for yourself, as opposed to like just taking a class and doing a tutorial. And think beyond. I think a lot of us in undergraduates or even in grad school or even in careers after, sometimes you end up being passive and don't think too far ahead. And it's important to think too far ahead and plan things, but maybe still be flexible. So this can help you have a strategy, but also able to adapt if things change. Specifically in terms of innovation and in undergraduates, what helped me was I took interesting classes like robotics as a side, like a class in level 4, and I did some reasonably interesting research projects in undergrad and managed to publish some of this in local conferences. I also did well academically, and all of these things combined allowed me to try for and get several interesting PhD opportunities, and I ended up doing my research at MIT. But one key thing here is kind of taking the time to explore these opportunities and actively finding problems or trying things, and also finding the opportunities that you want to take. If you're more passive and not willing to take too much charge of your life or direction, that I think hurts you more than anything else. This is more just giving people my background and my expertise, and not an advertisement or an advocation to go abroad and study or anything like that. But there are different postgraduate opportunities in local and foreign universities. And in terms of foreign universities, at least some of the top ones are in America, Australia, Japan, UK, Europe, and they all come with different positives and negatives. Since I didn't do postgraduate studies in Sri Lanka, I can't speak too much in detail about it, but I know that a lot of good people that I've studied with who've gone abroad and come back into a lot of our universities are bringing that knowledge and research opportunities and innovative thinking. And I'm not saying that people who didn't study in other countries don't have innovative thinking, I think, but it helps to broaden your horizon and get a lot of those expertise. And I think that's happening in Sri Lanka as well. And I know people who do masters. I'm gonna more talk about some of the opportunities that I explored abroad, at least, and hopefully that's useful. And maybe certainly the research things that I will talk about more are applicable wherever you study or do research or do innovation. For myself, at least, especially if you're applying abroad or thinking about opportunities abroad, you have to plan ahead. A lot of these applications take time and take a lot of researching, because there's so many opportunities and so many things, so many labs that might be interesting. You can't like apply to 500 universities, 500 applications. So you have to find the right opportunities, find the right system that might work for you. Like, for example, US allows a lot more research or freedom for exploration if you're doing a PhD, whereas Australia, Europe, they're faster in PhDs, but maybe you you start a non-project and you have less time to explore and try out different ideas. And a lot of cases, labs matter more than universities. So it's more the interesting labs that do cutting edge research as opposed to looking at the name of a top university. In a personal note, I applied twice to MIT. The first time, I didn't really know what I wanted, and I wasn't really clear on what I wanted to apply myself to, and I didn't get in. I didn't really put the time and effort needed for that application. And the second time I took the time to think about what I wanted, and I knew the type of research I wanted. I framed my application and my background in a way that actually attracted the right amount of attention. And in reality, I didn't really have anything additional in my resume or anything like that. It's more about targeting yourself and focusing and really taking the time to know the audience and doing the effort to uh, show an application in a good light. And again, grad school is more advanced than undergrad, but it's still part of the journey. Sometimes people go into academia afterwards, and sometimes people, I for myself in undergraduate, I thought, oh, grad school, then you want to be a professor. I didn't want to be a professor, but in reality, lots of people in grad school end up joining industry. Even sometimes professors now join big companies and do industry work as opposed to like teach all the time. So it's still a journey. It sets you up for other things, and maybe grad school is not the right way to go as well. So lots of smart, innovative people that I know working in these companies, some of them haven't gone to grad school, and there's a cost and an opportunity for grad school, just like lots of other things in life. And the good thing is, I think our skill sets as Sri Lankans are good enough, certainly for like state-of-the-art research. And I think even in the past and even in the more recent past, there's lots of Sri Lankans who go on top universities and top companies and excelled. So that's that should be something that gives people some confidence, I think, as well. It's the thing that's kind of sometimes lacking or a little bit less developed is more the opportunity, like the mindset and the attitude. And this may be not just necessarily for postgraduate research opportunities, just maybe our mindset about taking risks and trying out things that can fail. And that's innovation, learning, all of these things come with some risk, and you need to have patience, and you need to try and fail sometimes and try again and then finally succeed sometimes. And that's kind of the process that helps you in life or in research or in doing any new thing. A big gap, at least, for like really exploring postgraduate opportunities in general, especially in the top places that set us back, is kind of not having sometimes the working with recognized researchers. These things kind of matter when people are applying or publishing in recognized conferences. And I think some percentage of people actually do that, and they definitely get in. But I think we can do more to do interesting research, but also publishing in conferences and publishing in top conferences. And I've seen people do it in Sri Lanka. In undergrad, people have done that. And I think that's pretty remarkable. And I think growing that kind of publications and skill sets, that's something that can help you kind of go to the next level or be recognized and go into like pretty top end universities. And I think the other good resource that people can use is kind of talking to people who have background in research. Working with people is the best thing. So if you have that opportunity, and I think in MIT, I was not an undergraduate in MIT, but we have undergraduate students who come and work in the summer with us on projects. So it kind of helps them to build up their research skills, publish in conferences, get that process early. Unfortunately, I think our universities, even universities that have masters and PhD programs, don't have it to the level that at scale that other top universities in other countries have it. So there's not as much opportunity, but I think doing that more and growing that more can help you kind of grow your skill sets. And I think people who've gone abroad that have come back, or even people who are abroad, like if someone emails me, I'm always happy to help someone out or give advice or talk to someone. And I've had people who kind of reached out and asked for application help and things like that. And I think there are tons of people like that, and you can talk to these people, try to kind of learn from their experience, and also sometimes they might actually connect you with people that might have interesting opportunities. So, but these require like taking active steps and taking the initiative. And sometimes I think that's what holds us back, as opposed to the knowledge and the skills. The knowledge and the skills, anyone with enough right thinking and intelligence can learn that. That doesn't necessarily hold you back, but it's more the initiative that sometimes is lacking and sometimes holds people back. And a lot of PhDs and masters, they focus on research. So GPAs matter, but that's not the main thing they're looking at. Is how will you do in kind of doing challenging things, finding problems, finding the right problem and knowing how to solve it and approaching it in a methodical manner and kind of removing the ambiguities and actually coming up with an innovative solution. So taking classes and getting good grades is one signal, but it's not the main signal. And so that's where like doing research and innovative things are much better signal that people look at in these kinds of fields and applications. And I think in lots of cases, the challenge in PhDs is not really the solving the problem. Solving the problem is somewhat easier depending on the project problem you find, but it's more the finding the right problem and finding how you can contribute to that problem and solving that problem in a way that actually adds something, but also makes it tractable. I think I'm done giving advice for a bit, and I'm gonna just talk a little bit more about my background. At MIT, I did my PhD in robotics and machine learning, and my thesis was on semantic mapping and natural language. It's been a while, so I'm probably a bit fuzzy on it too, but basically what we did was kind of bridging robotic mapping and natural language understanding. So you can teach robots to interact in human environments by not just allowing them to use their sensor data only, because that's what camera images and these lasers that project light into the world and understand distances, they're not how people think. But as the way robotics is going, you have robots that operate in human environments like hospitals, schools, campuses, and other things. And you want to interact more naturally with these robots. And what my focus was on kind of bridging the gap between how robots see the world and how people interact with the world, kind of building these maps and representations so that people can communicate and instruct robots to follow directions and provide useful behaviors using natural language. And one like life skill I learned was kind of reading papers, learning new things, learning what are the problems, what are the right problems you want to solve, and kind of scoping out things in a solvable way. And the work I do in after grad school, they have not been like directly applicable sometimes to your PhD topic. A lot of PhD topics are very specialized, and sometimes people found companies on them and go down that path and still maintain that continuity. Sometimes you go to industry and not necessarily directly apply some of these things after graduate school, but it's more the skills that you learn, skills of approaching problems, learning to solve problems and doing it in a way that, in a feasible way and a innovative enough way that actually solves a problem. So, and that's kind of the mindset that you carry forward from graduate school, especially to academic industry. So this is kind of the idea here, but I'm not going to bore you with details. But let me see if I can add a old video. Maybe I can show you. So the idea here was that you have this robot. I worked on this robot platform, this wheelchair robot. It's kind of a mix of assistive robotics and indoor robotics. The idea here is kind of you bring a robot to a new environment, you walk around with the robot, you're giving it directions. The robot has a lot of sensors on it here. There's like lots of these things called LiDARs that give you distance across a 3D or 2D view of the world. And this kind of tell you about, okay, what's the layout of the space, maybe even the type of rooms and things like that. The language part provides you additional information that people understand about the world, or this room is connected to that room. You refer to a certain room with a specific name, things like that. And through that, you can build maps of the world. And the big part of robotics is about building maps, at least in the old days, and build maps and also kind of follow directions sometimes, or even like go into a new space and someone gives it a set of directions to follow or an action to do, and it can perceive the world, but also use the information that a person is providing and carry out a useful set of actions. So a lot of robotics is about sensing and doing actions based on sensing, just like people. You see things, you do things. And that's kind of what robotics at a very high level is. I think I kind of covered this finding the right problem part, but the other thing is kind of be motivated and taking the initiative. And sometimes advisors can be helpful, but a lot of these things are left up to you. And that's a gap between undergraduates versus PhD, or even in work, that there are no people, like there's not a very set path for you. And no one's really like in charge of making sure that, okay, you are going in the right direction. Some people are like managers or advisors, but a lot more things are up to you. And that's the kind of thing that I think you want to get adapted to. And the more initiative you take, the more successful you are, independent of innovation. And another thing I think a lot of us sometimes neglect or aren't really that good at is kind of building relationships and networking in grad school, in work after that. Either way, it's like a very useful skill and may not necessarily apply to innovation, but it certainly applies to learning and growing and being successful. So it's a very useful life skill, and that's something that you want to kind of develop. And communication skills, especially, whether it's publishing, whether it's reaching out to people for networking opportunities or labs or any of these things. Those things are good things to develop in parallel with other things like reading papers or doing interesting projects and things like that. Anyway, we have some time, right? Okay. So after my PhD, I went and joined Google Robotics. I don't know if some people know about Boston Dynamics. They built these humanoid robots. I didn't work specifically on those, but it was part of the larger robotics project. I was there for about a year. And then after that, I've been in self-driving vehicles. I've been working on perception and machine learning for a long time. I was doing these object tracking kind of problems. Now I'm a bit more very onto the machine learning side, and I'm these days on a very managing and tech leading the machine learning team at Cruise. So I was at Waymo / Google autonomous vehicle project called Chauffeur for about 4 years. So on top here, the two cars are the platforms that I helped develop for a good chunk of my career. And after that, I went to join Toyota Research, which is the second car you see bottom, again in self-driving. And finally, about 7 months ago, I joined Cruise. It's another self-driving vehicle. Both Waymo and Cruise, we have fully driverless deployments in several cities like San Francisco, where there are no drivers in the front seat. This is a big change since I joined versus now. And for a long time, we were kind of skeptical that this could be done. But so I see lots of progress and lots of things change, like the approaches we took to solving some of these problems at the start at Google Robotics. And I joined the Waymo self-driving project when I joined are not at all the things that we use now to solve some of these problems. So even within like 5-6 years, a lot of these fields have changed so much. So I think that's where I think being able to learn and grow and change with how the world changes is a very useful skill. And that kind of keeps you from stagnating and innovating your personal approach to things. So that's kind of one highlight I want to say. This is a very idealized view, but this is just how one of these cars kind of see the world. You can see a bunch of objects. You can see these things with cameras and LiDAR sensors, and there are lots of different algorithms and things operating on these inputs to detect these things, detect pedestrians, cyclists, vehicles, and then continuously track them to understand how they're moving, what speed they're moving, and then a planning system and using that you can predict what kind of actions they will do, and then based on those actions and where you want to go, you kind of plan a path around these objects, just like we do, but maybe a little bit differently. And so it's an interesting problem, but at least that's what I've been working on for the last 7 years. This is a video from Waymo. Anyway, and I think the roles that I've played, at least, have been more on applied research and development. So it's a mix of deploying things on somewhat real world platforms and solving problems that may not be like very abstract problems, but problems that are things that people have not encountered before, because a lot of these kinds of applications did not exist 5 years ago. So, and solving these challenging real world problems in self-driving. So it's been an interesting few years, and hopefully some more years before we actually fully solve this problem. So interesting things to do. Anyway, I think, yeah, okay, a couple of more slides. It sometimes depends, like not all jobs or work is gonna allow you to solve cutting edge problems. Sometimes you get lucky and it works out like that, but there are still problems and innovative solutions, and being able to innovate and solve things and come up with solutions that work applies not just to cutting edge research, but to lots of things in lots of times in your life and in things that you do at work. And things can change. So I think being willing to change is kind of self-innovating yourself and your skill set. So that's kind of a high level innovation, I think. Anyway, I think maybe I'm a bit shorter, faster, but that's kind of the talk I had. So it's kind of a lifelong journey, I think, at lots of different times you can innovate, and I think you can innovate differently, but certainly grow yourself and have a large impact. And I think being open to these changes, and sometimes changes are painful, but they help you grow your mindset and your skill set. So I think it's sometimes good to think about changes and be prepared for changes. It's gonna help you become a better person sometimes. Anyway, I think that's it. Hopefully, I like to answer some questions or have discussion if people have interesting questions.
Okay, thank you very much, Dr. Sachitra, for a wonderful presentation. I mean, even I got a lot of perspective to what innovation and how we can be very spontaneous, and it can come in different parts of your life, not just postgraduate or graduate life. It's quite amazing to hear from you. I think we are moving on to the Q&A session, as you can see on the screen. Now, just like in a usual webinar, the floor is open for any Q&A, so you can directly unmute yourself and then ask directly question from our speaker today. But also, you can, if you're not feeling well, do that, and if you are not confident enough, you can use the chat section as well. You can post the questions there. So we'll break some mics. I want to ask this first question until we get the questions in. Now, being a staff research scientist in Toyota Research Institute is it's not an easy achievement, I believe, as a Sri Lankan engineer. It's kind of a huge deal for a Sri Lankan engineer. So, and it's a great opportunity as well. So can you share thoughts about your achievement of being a staff research scientist in Toyota Research Institute?
uh, I a lot of these are like interesting opportunities. Sometimes the titles matter, sometimes the titles don't. So I think it's more about the kind of things you get to do and um, kind of the impact that you can have. And I think maybe during like at least in the careers that I've had and I've seen in kind of these Silicon Valley companies and tech companies, most people start out as like a individual contributor. You have your own scope of work. You kind of solve a problem. Sometimes you work in a larger team as a part of that team and solve some part of the problem, or maybe you have individual pieces. And I think as you grow, sometimes you get the chance to have broader impact. And typically, like senior scientists kind of tend to have more broader impact, but tend to do still more individual work. And as you grow in your career or grow in your skill sets, having like a larger set of people that you can coordinate and lead allows you to kind of have even larger impact and solve bigger problems. And a lot of these bigger problems need a lot of coordination. So I think in my role at Toyota Research, I got to we had this challenge to do this Olympics demonstration, self-driving deployment. Unfortunately, the coronavirus came and kind of messed things up, but almost until the Olympics was closed to the public, we were working on this deployment, and I got the opportunity to kind of help shape a lot of the perception work that happened on the Toyota Research vehicle. So I led the tracking team, and I kind of helped lead the perception stack, which includes like taking from sensor data, you kind of detect things around the world from LiDAR and cameras, and then you kind of build a cohesive picture across time in this tracking kind of thing where I saw like some vehicle at some point 0.5 seconds ago, now it's here. And based on the sequence of information, you kind of build up this estimate of what this object is doing based on the past. And then this gets handed over to kind of this prediction stack that predicts how it's going to move based on what you told them and what the world looks like and what these models have been trained with of how objects interact. So I think there I got the role to kind of lead this team, coordinate a lot of interesting technical projects, and saw this in a way that I think we did some cool stuff, and that was an interesting time in my life.
Indeed, it is, and it's kind of interesting to hear the experience that you got. I mean, it's truly remarkable and amazing. So thank you very much for joining with us. I mean, sharing the mere experience inspires us a lot. All right. Now, when I was reading this, the profile of yours, I came up with this term roboticist, if I'm pronouncing it correctly. Now, I think this is a globally recognized status. So can you tell us about this, the status, the roboticist? So what are the qualifications that we need to satisfy the global status of being a roboticist?
Yeah, robotics is kind of this interesting field. It's a mix of different things. So it's a very broad field, I think. And I worked with people who come from math backgrounds and mechanical backgrounds, biomedical backgrounds. I came from an electronics background. I'm doing much more like computer science and engineering now, so in grad school and now. But I came to this from like electronics background. So I think it varies. Robotics could be a lot of robotics that I do are more in graduate school. I wore more many hats. Like that wheelchair platform you saw, I kind of maintained the large system. Did a lot of these navigation algorithms as well as sensing and mapping algorithms. So lots of robotics people can wear a lot of these hats. And now I do more focused on perception. It's still a larger robotics problem. And because you're sensing with these sensors, you're trying to understand and build a representation of the world. And then you have to act because you need to do something useful, like drive or move around or go pick up an object and bring it to someone's desk, things like that. So that's the larger robotics problem. So people in different pieces of that problem are generally referred to as roboticists, or people who kind of specialize in more the system level thinking. And that's kind of where I kind of have experience as well. So that kind of helps you think a little bit beyond the smaller picture, but also how it kind of connects together. And it's a kind of a niche skill, but that's kind of a useful skill too.
Thank you very much for the answer. I mean, got a lot of insights about the roboticist and the quite big spectrum that we have. So thank you very much for your answer. And now we'll come towards a different direction. If you come to innovation now, as an innovation with a lot of ideas, the patents have something quite cumbersome. Like, I mean, a lot of people have this question: how can I get the patent to my innovations or my invention? So how can someone proceed to the patent?
So I think these patents are like things that companies apply for when you're doing the research. So the way is, if you're at a company and doing research, the patents, you are the inventor, but the patents belong to the company. And so in that sense, if you're working at one of these big companies, a lot of the kind of the background is that you think of an idea, or most of the time you solve a problem already that actually needed to be solved. And then after the fact, you might think up a patent based on what you did and how you solve that problem. And then typically lawyers will kind of draft how this in a general enough way that you approach and solve the problem, and they kind of handle some of this filing the patent. I personally don't have as much weight on patents, just depending on like how they get used. Sometimes companies just exist to like file abstract ideas, don't actually do these things, and then sue people. This is not like the companies that I work for, but there are kind of these companies called patent trolls and stuff who just basically patent an idea. And getting a patent sometimes is not the hard thing, because you apply and come up with like a novel kind of sounding concept, and then typically the patent office will grant the patent. It's more when it actually needs to get resolved, or someone sues, that they kind of look at the patents close enough and say, oh no, this is prior art, people have done this 20 years ago. And then sometimes they even invalidate patents. So it's something that sometimes holds prestige as well, but it just depends. It's kind of, sometimes I personally treat it just more of an artifact of doing interesting things or solving challenging problems, as opposed to getting the patent itself is not at least my motivation. And I have few patents and not focus too much. And typically like companies have these trade secrets, basically how you solve the problem, and not all of these end up being patents because it's not worth the time, or maybe you don't even want to expose some of these ideas because you have to publish some of these out when you publish patents.
Okay, thank you very much. So I hope that query has been clarified. And we have an interesting question from the chat section now. I think this question is quite valid when it comes to Sri Lankan context. Now, because of the education system that is prevailing here in Sri Lanka, age is kind of a big deal, because some of the students graduate quite a bit in an older age when compared to the other countries. Now, one of the audience's members is asking the question: does the age matter when starting a PhD?
I don't think so. I mean, unless you're like 40 or something and applying, maybe it matters. But it does. Typically, a PhD has a mix of people. So sometimes it's people who come straight out of undergraduates and directly start on the PhD, and that's maybe a good chunk of people. But then there are people like, even I worked for a couple of years and then I went to the PhD. Similarly, there are people who work at companies. Sometimes they want to do a PhD and then they might go back to industry. So it doesn't necessarily matter, like, especially like a couple of years here and there, like at the end of the day, it's more a number as opposed to something that matters.
It's just
and
a
like,
number.
Yeah, it doesn't really like affect things on like the chance of you getting into a PhD program or anything like that. But then again, like if you have family and other things, the cost and the benefit you get from doing a PhD might be different than if you're like someone young out of undergrad. So that's kind of where things may become different. But that's more on a life cycle. So if you want to do a PhD, I don't think it really matters what age you want to do the PhD at.
Indeed, age is nothing but just a number. So thank you very much for your answer. And we have another question from the chat section from the audience. What are the job opportunities and fields for electronics and telecommunication engineers in Sri Lanka and other countries?
I think it depends. I think like, I don't know how electronics and telecommunication is now. I think I heard from talking to people a while ago that there are like different specializations. You can go into biomedical stuff or very like
here in
electronics.
University of
Yeah, at least in the University of Moratuwa program. And that's, I think, depending on where you focus on, there are different opportunities. I know a lot of my colleagues, we were focusing more on this telecom side of things. A lot of folks went to Dialogue and Mobitel and places like that in Sri Lanka. And I know that a lot of people who are there now, they went to Australia and other places. Some went to PhDs, and some are working in similar companies in other countries. And I think there's other opportunities in terms of like integrated electron. I think the way we can contribute more, especially in Sri Lanka, is kind of more on kind of this electronics and hardware side of things. I think we have a good opportunity to grow and expand those kinds of industries. Telecommunications and other things in those days was the big thing. And I think it certainly adds a lot of utility to people's lives, but there are definitely like other interesting areas that people can contribute to. And I think a lot of people, depending on their skill sets and interests, have a good background in computer science and programming and things like that as well, even though you come out of the electronics and telecommunication program. So that also opens up a lot of opportunities, I think, for like programming in other countries or in Sri Lanka.
Right. So to mark the conclusion of the Q&A session, I have one more question. I think this is kind of like a objective question. Finally, let's talk about, now we have been talking about this innovative invention full engineers, but what kind of skills, specific skills that we should improve or develop if you want to be an innovative engineer in future?
Can you say that again? I need to think of
that. What kind of skills or what kind of things that we should follow in order to be a creative or innovative engineer? A specific skill set, is there like a well-defined one?
I think the skill set itself is kind of like, at least the technical part of it is dependent on what kind of field you're following. I think the main highlight I think I was trying to make is kind of taking the risks and trying out different things. And I think if it's especially like a research kind of engineer or like things you want to really innovate, I think you want to read up on papers and things like that to kind of understand where the industry is and where the cutting edge things are happening, because that brings you up to date into state of the art. And then kind of, if you have a problem that's already been solved, you know how to solve it. Or I know I have a new problem, I know what people have tried, how people have approached this. So then you know how to actually focus your effort into other more like potentially beneficial kind of approaches. So that's one aspect. I think I think in general, I think just growing your skills and taking the chances on some potentially risky things. Maybe not everything has to be risky, but trying some risky things helps. And I can't say that I've been the most riskiest person. I think there are lots of people who take lots of risks and do startups and spend years on startups. And I've kind of thought about it. I haven't done it at least yet, but I know people who go to startups further along. So a lot of these things like age is not really necessarily what matters. Sometimes though, your life circumstances do matter. That's like if you have family and kids and stuff, maybe the chance that you can take the risk is less than if you're like younger or less constrained in terms of other things.
All right, I believe, thank you very much for this.
I think that's one question.
Okay, yes, we do have one. So could you please share your experience in Google Robotics as a roboticist?
Google Robotics was kind of this mix of companies, and I was there for a year. I did more like some amount of robot mapping and navigation work for indoor robots. It was a little bit of a chaotic project, so that's why I was not there for longer than a year. So I can't say I really have a lot of experience to share on that aspect itself, but in general at Google, I learned a lot of useful skills on like how big companies work and a lot of skills on like coding and other things, and getting and Waymo / this Google robotics car project was a opportunity to learn a lot of things, both from people who kind of been working on that field, but also then kind of the challenges that we were facing. They were cutting edge and get to solve these problems for the first time. And that's not especially in the earlier days on those projects, there was not that much publications and literature around how to solve some of these problems. So you were kind of figuring out a lot of these things. Now there's a lot more publications on a lot of these aspects. And the Google Robotics project, I think, so it was part of this Google X company, which had, it's like a kind of incubator within Google. And there are actually several of those projects have recently been spun out into kind of individual companies. I think one is called, I forget the names, but if you search for like Google Robotics projects, there are like a couple of projects. One is kind of this indoor navigation robot that can pick up objects and clean things and take trash out and things like that. Another one, I forget exactly if that one is public, but I kind of finish with that.
Okay, so with that, we are marking the conclusion of the Q&A session as well. Thank you very much once again for those valuable insights. I mean, it is an honor and a pleasure to have such a experienced personality like you with us today. And thank you very much for joining with the Q&A session. And also we have, as the IES UYY, we have created this small token of appreciation for Dr. Sachindra Chandra for joining with us as the keynote speaker for INVEN Ovations 2020 episode 2nd, organized in collaboration with the ISL student chapter of University of Montreal. Thank you very much, sir, once again for being a part of today's presentation and the session. And it's totally an honor to host you and to have you here in this virtual experience. Thank you very much.
Thank you very much. Have a good day. Thank you very much for having me.
Now, okay, so now this is an open invitation to all our participants. We'll be taking a group snap just to make this moment a memorable one with our speaker, Dr. Sachindra Chandra. So open invitation to all of our participants to switch on their video. Also, you can use the virtual background, which is available in the chat section. Just pop it on, and then we will have the group photo, and our organizing committee members will help us in taking the photo. Yes, open invitation to all of our participants just to turn on your video, and if you are comfortable doing so, just do so. If it is possible, also just have the virtual background that I'm having right now with the innovations. You can have it in the chat section. It's available there. I only see 6 yet, so okay, guys, come on, just we'll take a quick photo. Can someone help me with taking the photo? Nikesh Yaki, would you be able to do that?
Okay.
If you can't take the virtual background, it's okay. Just turn on your video. We'll take a small picture. That's all. Thank you.
I'll take photo. Wait a moment. Thank you for this taken.
All right, thank you very much, Ms. Nikesh Kumar Singh for the assistance. With that, we have come to the end, but before that, we have special parties to be thankful of for joining with us. So let me kindly invite Mr. Lakshan Javira, Chairperson of INVEN OVATIONS, second episode, to deliver the vote of thanks.
Good morning, everyone. It has been such an honor to be a part of this wonderful event. On behalf of the organization, I would like to extend my heartfelt gratitude to our esteemed guest, Engineer Kasun Pereira, Chairman of IESL JIY UIY Committee, and today our keynote speaker, Dr. Sachintra Hemachandra, Tech Lead Manager in Perception Cross. Thank you all. Thank you very much for sharing your knowledge with us. My sincere thanks to heads of all the departments who handled the event throughout. Thank you, Executive Committee of the UIY, Chairman, Vice Chairman, Secretary, and Treasurer. Thank you. Thank you all the IESL student chapter chairmans. Thank you all the teams of UIY, designers, editors, social media administrators, and organizing committee. Thanks to all the participants who had made the event a memorable one. Finally, I would like to thank you everyone who has joined us today for spending your valuable time with us and for helping us to make this event a success. Thank you, everyone.
All right, thank you very much. That was organizing committee member IESL UIY for 2020, Lakshan Javira. Thanking you all for attendance. And with that, we have come to the conclusion. But this is not the conclusion, yet a beginning of another amazing journey. So thank you very much for joining with us. And don't forget that we'll be having a special event tomorrow at 10 a.m. That is the official launch of the UIY, which is Undergraduate Inventor of Year 2020. The competition will be launched tomorrow with the grace of a special speaker, one of the masterminds, tech mastermind here in Sri Lanka. Dr. Beshan Kulapala will be gracing us that as the keynote speaker for tomorrow's session. And that will be happening via Zoom around 10 a.m. So open invitation to all of you to be a part of the launching ceremony of Undergraduate Inventor of the Year 2022. So with that, we have come to the conclusion of INVEN OVATIONS second episode. You might notice that I've had a hard time pronouncing the word name. Anyhow, the entire effect of this series was given to you, and taken to you just to have a amazing competition with the Undergraduate Inventor of the Year, because as I mentioned before, this is the most important time of the year. This is the most important time, the period in Sri Lankan history, because at the moment we need innovation, we need new ideas, we need novel opportunities, novelty in order to bring our country back to its race once again. So open invitation to all of you to the launching ceremony. And please remember that your ideas, your personalities, your novelties, your innovations are going to be important in this long-term run. So let's get together and build this country once again. And IESL UIY and IESL YMS and all the IESL chapters are ready to empower youth just to achieve that goal. With that, I'm concluding today's session. I'm your host for the day, Shahan Paul. Thank you very much for joining and have a nice day.